Good morning, Troy.
How's it going?
Good. Nice to see somebody.
Yeah. On Tuesday I was trying to get on. I was trying every password. I don't know if I was clicking on the wrong links or what, but
You weren't the only one. Zoom didn't cooperate very well on Tuesday,
okay.
but the video's up on YouTube if anybody wants to go watch it.
Yep.
Then we'll wait a minute or so, see if anybody else shows up. This probably won't be a very long class since we only have 5 homework problems. What's going on, Nick?
Oh, not too much. I'm just washing my dishes while I watch the class. So that's why my video's off, so I don't distract anyone.
That's fine. I see you got your quarantine beard going.
Oh yeah, it's been going on a while. I give up.
Everybody does. Alyssa, how about you? You got your quarantine beard going?
No, I don't.
Is that why you're not showing your picture? Just kidding. Oh, well, you should be able to see my Educat screen. Is that correct?
Yeah.
All right. So here's the lecture from Tuesday. This is the end of chapter problems we're going to talk about today. And there's the other stuff that you can look at if you need to. And this is also up there. This is the instructor's manual. And the first question is a duration question, which is and I always have to remember how to do it. I mean, if you only do it once every 5 years, you're never going to remember it. And there is a formula for it on Excel, but I have actually never attempted to use it. But given the information we've got here, wants to know the Macaulay duration of an 8% $1,000 par bond that matures in 3 years. Year to maturity is 10%, and it's paid semi-annually. So you can see I actually did it 3 different ways. This is what I started off doing it. I started going across, and then as the more I mess with it, the more I realized that this is an easier problem to do vertically. But what we have to do here is we take the first cash flow and find the present value of it. Second cash flow, and what you also notice is that each cash flow for the Macaulay duration is multiplied by its place in the sequence. So this is multiplied by 1, this is multiplied by 2, 3, and so on till we get out here, and this is multiplied by 6, and this one's multiplied by 6. So this is actually the cash flows I'm working with down here. And so here is the present value of this one, present value of this one using 5% as the discount rate. Find the present values, and then you add them all up. And you divide by the current price, which is right here. And the duration is 5.43. But that's every 6 months. So I took it and then multiplied it by 2 and got 10, which is wrong. So then I went and looked at the solutions manual. And I looked at what they were doing and I got all confused. because what they're doing up here doesn't actually match up to the formula that's in the book. What I figured out is that they're just doing stuff out of sequence, so it doesn't really matter. So they're taking the cash flow, finding the present value of it, and then dividing it by the price, and then multiplying it by its place in line. Technically, I think that's incorrect, because if you look at the formula, I also found 2 websites where we can that have duration form calculators, make it easier. And let's see, they don't actually show the formula on this one. The other one I think does. Let's look at it. Okay. So the formula tells us to take the coupon times its place in line and then discount it back. And then this is the same thing. You do the same thing with the maturity value, which is going to be 1,000 times its place in line, which in our problem is 6, discount it back. And then you add these together and divide it by the current bond price. So this is the formula. And so that's the way I did it here. And the solutions manual did it out of sequence, but they got the same answer. So I guess I can't argue with it. But the mistake I made was that you don't multiply this by 2, you divide it by 2 to get the number of years, because this is per semi-annual period. 10 of these divided by 2 to get the years. So it's going to be 2.7 years. And so I actually did it right, except for this mistake right here. So when I divided this by 2, I got the same answer as the solutions manual. And as you can tell here, I actually did it 3 different ways to make sure that I understood what was going on. So over here, I have the coupon, its place in line, multiplied those together, found the present value, added it all up, and then divide by 2 to get the annual duration. So kind of cross-checking my numbers. And over here, I did it the way the book did it, kind of. Here's the coupon, here's the present value, here's this number times its place in line, all the way down, same numbers, same answers. So it's all good. And actually even better than that, if we use their calculator, where's their calculator? Here's the calculator on this website. So the base value, I changed it to 1,000. The annual coupon rate was 8%. The annual market rate is 10%. And the years to maturity, 3. And I hit semi-annual, calculate. Scroll down here, and 2.7174 is the duration, and the modified duration is also calculated for us. So you bookmark this one. This is pretty nice, and you can cross-check it with the homework problem because it matches right up. Here's the modified duration here, which is the Macaulay duration divided by 1 plus the yield to maturity. So this is, let's see, this should be 1.1 because it's 10% yield, not semi-annual. 2.47, 2.588, huh? Wonder why that's different. If I leave this at 1.05, which is the semi-annual interest rate, 2.58, 2.58. That's interesting. I wonder. Let's be careful with this modified duration. This appears to be using the semi-annual interest rate the way I did it the first time. But the formula says to use the yield to maturity, which is 10%. So it should be 1 plus 0.10. 2.47. So let's see what the solutions manual says. Huh. Well, they divided it by 2. So evidently we use the semi-annual. That's interesting. I can look at the book real quick. I have it right here. Modified duration. Yeah, okay. So they use the interest rate per period for that. So I'll change it back. Didn't like it, huh? Okay. There you go. Good to know. So B says percentage change in price equals minus duration times the change in price. So if the bond's yield to maturity drops 0.5% or 50 basis points, the price will rise 1.294%. Minus 2.588 times minus 50 divided by 100, or minus, what would you do that? 0.001, 0.5%. So if interest rate drops, price of bond will go up. Good enough. 2, let's see one thing here. Okay. 2 says a bond for this corporation has the following characteristics. The maturity is 12 years. Coupon's 10%. Yield to maturity is 9.5%. The Macaulay duration is 5.7 years. And convexity is 48. It's non-callable. So calculate the price change of the bond using its duration if the market rate goes up 150 basis points, which is the same thing as increasing 1.5%. So the formula is minus duration times, I use the basis points again, 150 divided by 100. And the answer is negative 8.16. So if interest rates go up, we would expect the price to fall, and it should fall 8.16%. B says, what does it say? The yield to maturity declines 300 basis points, 3%. So just out of 300. I'm just wondering what happens if we change this to up here, a negative 3%. See what happens. See if it changes the answer. It shouldn't. Bingo. So you can either use the basis points or percentage up here. See that? 3.3% is the same. 0.03 is the same thing as 300 basis points. So if interest rates drop, we expect the price to rise. If it drops 3%, the price will go up 16.3%. That's pretty good. Double check that. There it is. I'm a happy camper when that happens. Oh, and then it wants to know and see, calculate the price change for the bond using both duration and convexity in the computation. Again, decline of 300 basis points. So here, instead of using basis points, they actually use 3%. Minus duration times minus 3% plus 0.5 times 48, which is given to us as the convexity, times negative 3%, which is the change, squared. And this is formula 13.8 in the chapter. So the only thing that's given in here is 0.5. This is the duration, this is the interest rate change, this is the convexity, this is the interest rate change, and this term is squared. And I got 18.48. And the answer was 18.49. That's pretty close. If I rounded to 2, that's pretty, I don't know. That's not over 18.5. I guess it is 18.5. Yeah, 18.48, 18.5. All right. Then part D says, what would happen if this was a callable bond? Well, it would change the estimates and the volatility if we were trying to estimate the duration and the bond had a callable option. That would kind of screw everything up. And our duration and our prices wouldn't be very accurate. In a nutshell. Number 3, we have a bond with these characteristics: semi-annual coupons, coupons 8%, yield maturity is 8%, so that tells us it's selling for the same as its par value. It's selling for $1,000. Maturity is 15 years, and the Macaulay duration is 10 years. Hey, what's the modified duration? It would be the duration divided by 1 plus the yield to maturity divided by 2, 9.61 years. And then B, why is the modified duration a better measure of the bond's sensitivity to changes in interest rates? I think this is kind of an important thing that's got to be put in there for option-free bonds. It's a good choice. Better than maturity by itself, and because it also considers all the coupon payments being time-weighted. The Solutions Manual doesn't explain whether modified duration is a better choice than Macaulay duration, but since it's calculated off of it, I assume it must be all right. Identify the direction of change and modified duration if 1, the coupon were 4%, not 8%, and the duration increases as the coupon decreases. Well, what does that mean? That means the smaller the coupon, the longer it takes for the maturity, for the duration to hit. By the same token, if there's no coupons at all, the duration's equal to the maturity of the bond. If it's a 10-year bond, duration is 10 if there's no coupons. So the larger the coupons, the lower the number for duration, the faster you'll get your money back. Number 2, if the modified duration decreases, it decreases as the maturity decreases. Decreases as the maturity decreases. So if the maturity of the bond were 7 years instead of 15 years, the duration would be a smaller number. Well, it'd have to be, because if your term to your bond is 7, you're certainly not going to have a duration of 15. That doesn't make any sense. So, we could do some math examples and crank through that to see that that makes sense. But I'll just go with what they say for right now. D, define convexity. Explain how modified duration and convexity are used. Well, it measures the rate of change of the modified duration. So if we go back to our duration on the website, they're not going to show us there. That's what I'm looking for. So the convexity shows how the duration changes as the interest rates change. And So you can see this one is linear. This is the duration. And bond A is the most sensitive. You can see how it changes so much to the change in the yield and the bond prices. So convexity just measures this sensitivity. So if we're using duration and convexity, we actually have a better measure than just using duration by itself. And the example for that is in the previous problem back here. We can see that if we just use duration, that the price is going to fall, will increase 16%. But if we add convexity into it, we can estimate that the price will raise 18%. So a little more efficiency. Number 4. Following table shows the yields to maturity on Treasury securities as of January 1st, 2018. 1 year through 5 and then 10 years, and the yield on those different securities. And A, it wants to know the 1 year forward rate on January 1st, 2021. So this is 18, 19, 20, 21. So it's the 4th year. And as I explained Tuesday in class, that basically this 4-year interest rate is composed of 4 1-year interest rates. It has to be the same as the 4-year interest rate over. In other words, if you bought 1 year, matured, and bought the second one, cashed it in, bought the third one, cashed it in, bought the fourth one, the results have to be the same as buying a 4-year security. Or it allows for interest arbitrage to occur, and sharp arbitrageurs or financiers, or whatever you want to call them, could identify those inefficiencies and use that to make money. By the same token, you should also understand that any combination in here would be the same thing. So you could have a 2-year security and 2 1-year securities, or you could have a 3-year and a 1-year or a 4-year. So the interest rate parity in these has to be such that you can't make a profit because of a disparity in the interest rates. So what we've got down here in A is the 4-year rate is going to be the same as the 3-year rate times the 1-year rate. So in other words, if you buy a 3-year security and then you cash it in and buy a 1-year security, it's going to be the same thing as a 4-year rate. So if we know the 3-year rate and the 1-year rate and the 4-year rate, or any of these, as long as we know all of them but one, we can figure out the missing one. So the 4-year rate is going to be equal to the 3-year rate compounded 1 more year. So the formula for the 4-year rate is 1 plus the interest rate raised to the 4th power. The 3-year rate is the 3-year interest rate, 1 plus, this is supposed to be plus, sorry. Thought I changed that, I forgot about that. You can make that change. That's a plus sign. So it's 1 plus the interest rate raised to the 3rd power. And then, so we know this one is 1.055 right there. And we know that the 3-year rate is 1.05. It's 5% right there. What we don't know is what would be the 1-year rate here. So we had a 3-year rate and a 1-year rate. It has to be equal to this 4-year rate. So what we've got is 1.055, mess that up to a 1 period. (1.055) raised to the 4th power. And we have 1.05 raised to the 3rd power. And then we're going to solve for 1 plus this interest rate. This is what we're actually solving for. The forward rate for 1 year and 3 years out. So this interest rate is equal to 1.055 raised to the 4th divided by 1.05 raised to the 3rd. So we're just moving this over here and minus 1, and then we subtract 1 over here to get rid of that. So the futures interest rate, the forward rate for 1 year, 3 years out is 1.238825 divided by 1.157 minus 1, or 0.070143, or 7%. And that is the answer to that. And there it is right there. So then it wants to know, describe the conditions on which the calculated forward rate would be an unbiased estimate. And you just lift this out of the book. Same assumptions as the expectations theory. Must have been in a hurry when I typed this stuff. Number 3, on the basis of pure expectation theory of term structures, discuss 2 factors that could account for a decline in the forward rate. For a decline in the forward rate. Well, that could be just a change in interest rates going forward as interest rates fall. That would cause the forward rates to drop. Or lower inflation rates would do the same thing. How could the information conveyed by this observed decrease in the implied forward rate be used in making a yield forecast? Well, if you're using like financial forecasting, where you've got to put in interest rates to calculate future values, present values, yield to maturities, or yields, then calculating those forward rates would give you some numbers to plug in to your forecast. And I put, most importantly, to know are rates going up or down. Rates are going down, then your cash flows are going to go up, and vice versa. Number 5, consider the characteristics of 2 annual paying bonds with the same issuer, same priority in the event of default. Bond A is annual, 3 years to maturity, 10% coupon, 10.65% yield to maturity, 98.4 price, selling a little bit of a discount. Bond B, 3 years to maturity, annual coupon, 6% coupon rate, 10.75 yield to maturity, a little bit higher yield, selling a little bit bigger discount, 88.64, because of the difference in the coupon rates. And here is the 3-year spot rate going forward, 5%, 8%, and 11%. So what are we going to do with this? Well, now we can actually see where the arbitrageurs would be waiting to see what would happen. because the bonds price is not consistent with these spot rates. So using this information, we can price these bonds using the spot rates as the discount rates to bring the coupons back. So first coupon, $10, discounted back at 1.05. Second one would be $10, discounted back at 1.08 squared. And the third one would be the maturity value, and the last coupon, so it'd be 110 divided by 1.11 raised to the third power. That'd give us 98.53. And the bond is selling for 98.4. So what that tells us is that if these spot rates are accurate in the next 3 years, the price of the bond will actually go from 98.4 to 98.53. So actually will go up a little bit in the 3 years to come. That's where the arbitrageurs could take positions and make money if the yields don't change appropriately. We look at B, we do the same thing, and we find out that its arbitrage price, non-arbitrage price, is 88.36. 88.36 is only 2 cents difference from what it's priced at in the market today. So it's only going to go up 2 cents. So even though it's got a higher yield to maturity today, as these interest rates come into play over the next 3 years, bond A would be a better buy right now because we'll make a little more money. Now, one thing it's important for you guys to realize is that we could have done this formula over here by just using the present value formula. We could have said the rate is 5%. The number of periods is 1. And the future value is going to be 10. And that would give us the same number that this is, which is 10 divided by 1.05. So this is mathematically the way to do this. So if we had more calculations, say you had 10 or 12 or 15 cash flows, it would be much easier just to use the Excel, copy it and change the variables as you go. Because what you do is come up here and interest rate change is the same. It's going to be 2 periods. And the future value is going to be the same. And the third one, oh, yeah, that's okay. And the third one will be 3 periods. And the future value is going to be 110 because of the maturity value. If I did this way, this is going to be squared. And this one will be 110. And this will be exponent 3 because it's 3 periods compounding. The only difference is I just have to recognize that Excel's making these negatives because they're outflows. When you do it the old-fashioned mathematic way, you don't have that issue. So you can do it either way. So the answer to this is, even though bond B has a higher yield to maturity, because of the projected spot rates, bond A would be a better purchase. And that takes care of that. So when I looked at these problems and did in the chapter, I decided that that was enough. And took us 40 minutes to go through them, so that's not bad. So that basically wraps everything up. The final exam will open Monday morning at 6 o'clock. I'll email the password out tomorrow or Saturday. Check your emails, don't miss it, because otherwise you won't know that the password's going to be GO, G-O. So, and I will actually be on Zoom Monday from 12 to 2 if somebody wants to do the exam during that time in case they need to chat or ask questions. And you can also, if you're taking the exam other than that, you can email me or text me and probably catch me. Between 6 to 8 in the morning, I may not be functional, but I'll be around. So if anybody have any questions? No? Okay, so work on MindTap, get that done. That'll be open till Tuesday. And thanks for being in class this semester. I appreciate it.
All right, see you, Doc.
Okay.
See ya.
See you
Thanks,
later.
Doc.
Bye-bye.
Thank you.
Thank you.